Hello class. Today's recording, Illuminate recording, will be on Chapter 8 of your ER book. And unlike what I was doing in the previous sessions, I had you pull up your slides. Well, this time I'm going to let you read your slides on your own, and I'm going to ask you to go and get your book. So I'll give you a moment to go and pick up your book. Okay, hope you have your book by now. So today we'll be covering Chapter 8 of the ER book, further extensions of ER diagrams with binary relationships. So we are basically extending the ER diagrams, and we are on Chapter 8. So if you will turn to page 193 of the book, 193. That's where the chapter begins. Okay, I'm going to turn you to page 195. I'm going to ask you to move to page 195. And so you'll have to have your book open for this and listen to this recording. The first thing we're going to talk about is attributes of relationships. Well, we learned so far that a relationship is something that relates to entities. So we have, for example, on page 195, we have the student entity and the course entity. These two entities are related by the enroll relationship, and as per figure 8.1, a student must enroll in more than one course, and a course must have more than one student, must enroll more than one student. So in this case, if a course has only one student enrolled in it, it might cancel, because a student has to have more than one student. A course must have more than one student. It is an end-to-end relationship. Okay, so what we are talking about today is how we can have attributes of relationships. Look at the grade attribute. Well, let's go back to the definition of attributes. An attribute is something that describes an entity. But if an attribute needs more than one entity to describe it, then it becomes an attribute on the relationship. So for example, the grade attribute needs more than one entity to describe it. If I ask a student, what is your grade? The student is going to ask me for which course. So you will need to know the student as well as the course in order to know the grade that the student got in the course. So because the grade attribute is related to more than one entity, it becomes an attribute on a relationship rather than an attribute on the entity. Okay, so that's how we have attributes of relationships, when we have some attribute that depends on more than one entity for in order to get the full information. Okay, turning over to page 203, we just have a bigger ER diagram. We have students must enroll in more than one course. Courses must be taught by an instructor. An instructor may teach many courses, and so on. Okay, I'm going to have you turn to page 204. Again, we have, if you look at the figure 8.6, we have the time attribute on the class relationship. So the time of the class will depend on the course and the building. It depends on two entities at the same time. In figure 8.7, we have the room number also on the class relationship. Okay, the next question would be, how would you map these attributes on the relationship? Okay, for a second, I'm going to go back to page 195. We have the grade attribute. So how would we map the grade attribute on page 195? Well, what we do with mapping the attributes is the attributes go where the key goes. So in this case, it's an end-to-end relationship. So we are going to create a table for the end-to-end relationship called enroll. And in the table called enroll, there will be the key of the course entity, which is course ID, and there will be the key of the student entity, which is student ID, and both course ID and student ID will be underlined. The grade attribute will be right beside it, not underlined. It'll just be right beside it. It goes with the key, basically. So if we turn to page 204, for example, we have a 1 to M relationship, with the M being full. So we're most probably going to take the key from the building entity and put it on the course entity. So building number will most probably be a foreign key on course. So time will be an attribute of course. So the attribute on the relationship goes whichever direction the key goes, whichever direction we move the key into. Okay, page 207, we show another example of how a course entity the instructor entity develops into a weak entity of the course entity. And the next concept I want to hit on is on page 208. It's the concept of recursive relationship. What is a recursive relationship? So far we've talked about binary relationships, which is a relationship between two different entities. A recursive relationship is a relationship with the entity itself. It's a relationship within the same entity. For example, if we have in a company database a table called employee, and we have our 500 employees of the company listed in that table. Of those 500 employees, we have, say for example, 20 supervisors. But the 20 supervisors are also employees of the company. So it really would not make sense to create another separate table for supervisors. So what we do is we put the supervisor in the same table as the employee table. We just have an attribute for a recursive relationship. So in other words, there are some employees in that table which are supervisors, so there are some employees related to other employees in a different role. Okay, so basically when you have a regular employee table, if you think about a regular employee table, the employees would not be related to each other. But if there's a recursive relationship, then some employees within that table are related to other employees within the same table in a different role. So they're related to the other employees as a supervisor maybe. So if one employee supervises another employee, so we have some employees who are just employees, some employees who are employees plus supervisors. So we have relationships within the entities themselves in the same table. That's what's called a recursive relationship. So on figure 8.11 we have personnel. So one personnel may supervise more than one personnel. So the next question is, how do we map the recursive relationship? I'm going to turn you to page 223. which shows you how figure 8.11 would be mapped, page 223. Going kind of 2/3 way down the page, there's a table called personnel, which would have the first name, the last name, the middle initial, the employee ID of the of the employees, and super ID. Super ID is how the table is related to itself. So if employee 5 is being supervised by employee 10, then employee 10 is the super ID of employee 5. So to map recursive relationships, we take the primary key, put it back in the table using a different name. So we took the primary key employee ID, put it back in the table, and called it super ID, but we did not underline super ID. That's because it's a one-to-n relationship, so we did not underline it. So that basically is what a recursive relationship is. It's a relationship within elements of the same table. And when relationships exist within elements of the same table, it's called a recursive relationship. Okay, on figure 8.17, I wanted to show you how there can be more than one relationship between two entities. So we have a student entity and a faculty entity, and there is an instruct relationship, which is a many-to-many relationship, and one faculty may advise many students, which is a one-to-n relationship. And again, if you look at figure 8.17, there are attributes on the relationships, so there can be attributes on the relationships just as we talked about. Section 8.9, I talked about derived or redundant relationships. I'm going to let you read that on your own. But I'm going to focus you on to section 8.10, which talks about alternative notation for specifying structural constraints on relationships. Actually, I'll let you do the reading on your own, but I'll turn you to page 220, figure 8.21, and we will talk about the third type of structural constraints. If you remember, the first two types of structural constraints were cardinality constraints and participation constraints. The third type of structural constraints are what's called min-max structural constraints. And this is what we show in figure 8.21. The 1, 2 means a minimum of 1 student and a maximum of 2 students must be instructed by faculty. And a faculty may instruct 0 students and can instruct up to 40 students. So the 0 stands for the min and the 40 stands for the max in figure 8.21. Likewise, a faculty may advise 0 students and can advise up to 30 students. And students may have 0 faculty advisors or up to 2 faculty advisors. So the min-max constraint labels the minimum and the maximum that the student and faculty, rather the min-max labels the minimum and the maximum. When we were discussing cardinality, we just discussed a 1 or an n. So we say a student may have many faculty advisors. It's a 1 or an n. In this case, the min-max gives us a little more exact information because it tells us how many, if we know how many. If we know how many students a class can hold, we can say a class can have have 0 students, a minimum of 0 students, up to a maximum of 40 students. Or we can say a class can have a minimum of 5 students in order to make and a maximum of 40 students. So the min-max ratio gives us the exact numbers of cardinality. So the third type of structural constraints is the min-max ratio, which we are discussing in section 8.10. And with this, I'm going to kind of close the chapter. Those really are the 3 important concepts in the chapter. There's the attribute of the relationships and how to map those, the recursive relationships and how to map those, and the min-max relationships. and what they are. So I'll let you read the chapter on your own, and I'll let you read the PowerPoints on your own, and I will end the lecture right here. Bye.